Okay, so today we're talking about matrix operations, and we are going to discuss adding, subtracting, and multiplying by a scale factor. So a matrix is a way to organize data. We see this quite a bit when we're looking in Excel sheets or like a numbers, kind of the same thing. And it's a way to organize our numbers without having like descriptors on these numbers. Our computers are also working on a giant matrix system. So we can describe this matrix by its dimensions. So we name it by its rows and columns. So this matrix D here has 1, 2, 3 rows. So I'm going to say this is 1, 2, 3 rows. And 1, 2, 3, 4 columns. So this is a 3 by 4 matrix. So when I'm adding one matrix to another, or we can call them matrices, plural, adding or subtracting, they must have the exact same dimensions. So these are 2 by 2 plus a 2 by 2. So notice I'm adding the numbers that are in the same position. These are both in the top left-hand corner. So 3 plus 4 gave me the 7 here. So let's show why we might use this. So we have you don't have this slide, but a comparison between snowfall. So a normal snowfall year, or like what is our average, and then what happened in 2007. So what happened in 2007, matrix N is going to represent normal. So this whole thing here is a matrix, and this is another matrix. Matrix S is going to be our snowfall for 2007. We want to find S minus N. So S is going to come first, and then N will be here. So the top left-hand corner of S is 15.4, and normal snowfall would be 21.2. Well, what would I do? I would subtract those. So 21 point, that's a 1. Come on. 1.1 minus 15.4. And I just did that backwards. This number minus this number. 15.4 minus 21.1 gives me negative 5.7. Well, what do positive and negative numbers mean? Well, in 2007, we had 15.4 inches of snow, and our normal is 21.1. So we had below average. So a negative would be below average snowfall. And let's look at what would the next number in the matrix be. So snowfall in February, we had 33.6. My matrix is not big enough. And normal snowfall would have been 12.2. Well, 33.6 minus 12.2 is a positive 21.4. So we had well over average for a positive number. It'd be over the average. Now, I could continue this whole matrix, but let's go ahead and look at real examples here, or just number examples. So adding the matrices. So I am going to have the exact same dimensions. So I'm going to take negative 5 plus a negative 3, and I get negative 8. Negative 3 plus 4, positive 1. 0 plus 6 is 6. Negative 2 plus 0 is negative 2. You can work these out in your head or in your calculator. You should get the same. Just take one step at a time. All right, this next one, it is a 1, 2, 3 by 2 matrix plus a 3 by 2 matrix. So let's see here. When we add, we should still get a 3 by 2. So negative 1 plus 3 is 2. Negative 2 plus 5 is 3. 5 plus 5 is 10. Negative 6 plus negative 2 is negative 8. Negative 5 plus 0 is 5. and negative 2 plus 6 is 4. Close your matrix. Got a couple more here. Why don't you pause the video and try these ones on your own? Okay. Hopefully you pause the video. We have 1 plus 1 is 2. Negative 1 plus 0 is negative 1. Negative 5 plus 3 is negative 2. Negative 4 plus negative 5 is negative 9. Negative 6 plus 6 is 0. And 5 plus negative 5 is 0. Here's our new matrix. Be sure to leave spaces between here so we can see that these are different numbers. Otherwise, it might look like one big subtraction, and it is not subtraction. It is a matrix. This last one is addition again. So looking at my positions, negative 2 plus 3, 1. 6 plus negative 1, negative 5. Or positive 5, actually. 6 plus negative 1. Negative 5 plus negative 6, negative 11. Negative 6 plus negative 6, negative 12. 5 plus 1 is 6. Negative 2 plus negative 3 is negative 5. All right, subtracting matrices. So again, they must be in the exact same position to subtract them. So let's look at this example here. If I'm subtracting this matrix, we'll call this matrix A, matrix B. I'm subtracting them. I take the numbers in the same positions. 3 minus 4 is negative 1. So let's show this one out, and I'm going to subtract each one, and I'm going to show the work. So this would be negative 4, this number, minus, here, negative 4. Remember, minus a negative becomes addition. Negative 4 plus 4 is 0, so the first number, 0. Then we have negative 4 minus negative 3. That is negative 1. So the next number, negative 1. And lastly, we have negative 6 minus negative 3. That's negative 3. So there's our new matrix. Subtraction of this next one. Negative 3 minus negative 5. Negative 8. Negative 4 minus negative 4. Again, should be. Oh, I made a mistake. Take my time. Negative 3 minus negative 5. This becomes plus. So that should be positive 2. Negative 4 minus negative 4, so that's negative 4 plus 4, 0. Negative 5 minus negative 3, that becomes plus 3, negative 2. 4 minus 1 is 3. Negative 2 minus negative 3, that's negative 2 plus 3, which is 1. 5 minus 0 is 5. So not crazy difficult, but do make sure you take your time so you don't make those little mistakes in your head. You can do these in your head and then check with your calculator. That's a good method. Let's do our next ones. Why don't you try the next 4 on your own? Pause that video, and then you can jump in with us. So we are subtracting negative 6 minus negative 1, that's negative 6 plus 1, negative 5. Negative 3 minus 2, negative 5. 2 minus negative 4, that is 6. So that becomes 2 minus negative 4, which is plus. Negative 3 minus 2, negative 5. Negative 6 minus negative 1 became plus negative 5. Subtraction. 5 minus 2, negative 5 minus 2, negative 7. 4 minus 1, 3. Negative 3 minus 4, negative 7. 2 minus 5, negative 3. 6 minus 1 is 5. Negative 3 minus 3, negative 6. Couple more. 6 minus negative 1. Oh, we got to repeat here, so we'll leave that one alone. It's the exact same as this one here. Let's do this last one. 3 minus 0 is 3. Negative 6 minus 1 is negative 7. 2 minus 4, negative 2. Negative 1 minus negative 1, 0. Negative 3 minus negative 2, that's negative 3 plus 2, which is negative 1. 4 minus 0 is 4. Alrighty. Let's take a look. Now we're going to multiply the matrix. So this is called a scale factor. When we have a scale factor, we're sometimes doubling the matrix, or maybe we times by a half, so it's dividing it by 2 kind of. So we're halving it. Take a look. We'll have the number out front, a scale factor of 2, and we distribute that to each number. So 2 times 4 gave me 8. Then 2 times the 0 gave me 0. 2 times the 1 gave me 2. 2 times the negative 8 gave me negative 18. So let's look at this next one here. I'm going to take this 4 and distribute it to everything. I'm taking the matrix and I'm making it 4 times as big. So 4 times negative 5 is negative 20. 4 times negative 4, negative 16. 4 times 5, 20. 4 times negative 2, negative 8. So why would I want to use this? It says the drink menu from a fast food restaurant is shown below. The store owner has decided in order to make a profit on all of the prices should be doubled. So these are like, what does it cost the store owner to produce a small soda? It costs the store owner 95 cents. Well, he wants to make a profit on what he's selling, so he would double it. And something that would make him a little bit easier for him is if he puts all of his things that he can sell into a Excel sheet or a matrix and tell the matrix to be doubled. Well, just a quick little glance of what that would look like is our matrix is here. I won't write these all out, but 0.95, and we would have a lot more in here. And if I want to double that, I would multiply it by 2. And this is what this matrix would be, the sales matrix, what I would put on my chart that tells the customers how much each costs. So I'd multiply it by 2, which would mean that the small soda would now cost the customer $1.90. I could do the same thing for the whole matrix. So let's go ahead and do this multiplication. We are multiplying this one by a negative 5. So every single term gets multiplied by negative 5. Negative 5 times 2 is negative 10. Negative 5 times negative 6, positive 30. Negative 5 times negative 5, negative 25. Negative 5 times negative 1, positive 5. We have a 2 by 3 matrix here. 2 rows, 3 columns. 3 times 3 is 9. 3 times 2 is 6. 3 times 5 is 15. 3 times 0 is 0. 3 times 5 is 15. 3 times negative 1 is negative 3. The faster you are at your multiplication, the faster this work becomes. It's a great opportunity to practice your math skills. 2, we're doubling this matrix. 2 times 3 is 6. 2 times negative 6 is negative 12. 2 times negative 4 is negative 8. There's my new matrix. All right, so this time we are taking this scale, these two matrices, and we are adding them. But look at that. Matrix A, I want it to be 5 times as big. So I'm going to rewrite this. I'm going to rewrite 5 times matrix A plus B. So let's find 5 times matrix A. 5 times negative 2, negative 10. 5 times 3, 15. 5 times negative 4, negative 20. 5 times 0 is 0. Plus matrix B. I'm not changing matrix B at all. It stays the exact same. Now we add them. So, same position. Negative 10 plus negative 6. Final answer, negative 16 in that position. Negative 15 plus negative 4. Positive 11. Negative 20 plus 2, negative 18. 0 plus negative 9 is negative 9. This matrix here, this red matrix, is 5A plus B. Why might we use this? Well, for this situation here, we have a company that's manufacturing large steel DVD racks. They have different kinds. We have 3 different kinds of wood. If they want to compare their sales and find the averages, they may create these 2 matrices and add them together times by half, so averaging, which is dividing by 2, and find their average sales. So let's look at this next one. We have these 2 matrices below. We have got A and B. We want to find negative 2A plus 2B. So we want to change matrix A and scale factor of negative 2. So multiply by negative 2. For B, we're going to multiply by 2. So let's rewrite this. So 2A is going to be here. So let's go ahead and do that multiplication. Negative 2 times 0 is 0. Negative 2 times negative 6 is positive 12. Plus now, 2 times matrix B. 2 times negative 8 is negative 16. 2 times negative 1 is negative 2. Now we add them together to get our final answer. 0 plus negative 16 is negative 16. 12 plus negative 2 is 10. This is our final answer. You try the last 2 on your own and pause your video. Pay attention to order. We're doing the B first. Pause your video and try this on your own. Okay. Hopefully by now you paused and you can try it on your own. We are taking 4 times matrix B and we are adding that to 3 times matrix A. So 4B will come first and 3A will be the second one. So 4 times 4 is 16. 4 times negative 6, negative 24. Plus 3 times matrix A. 3 times 4 is 12. 3 times negative 1 is negative 3. Now for our final answer, we add those matrices together. 16 plus 12, 28. Negative 24 plus negative 3, negative 27. Final answer. And the last one. We want to find 6 times matrix B. So here's matrix B. We are multiplying it by 6. Take away matrix A. So 6B. Let's calculate that before we do our subtraction this time. 6 times 2 is 12. 6 times 4 is 24. 6 times negative 3, negative 18. 6 times 0, 0. 6 times 4, 24. 6 times 2 is 12, 12, 0. Take away matrix A. So I'm just going to rewrite, copy it down, matrix A here, just so I kind of have it in the order. And my final solution is now me subtracting these. I'm going to write my final answer. That's 6B minus A here. 12 minus 2 is 10. 24 minus negative 2. That becomes 24 minus negative 2. That becomes plus, so 26. Negative 18 minus 5, negative 23. 0 minus 1 is negative 1. And for the second row, starting with 24, 24 minus 1 is 23. 12 minus negative 6, that's 12 plus 6, 18. 12 minus 1, 11. 0 minus negative 5, that's 0 plus 5, which is 5.